This is Mr. Beck Does Your Homework, AP Physics, Homework 9.1, question number 14. 3 positive point charges are arranged in a triangular pattern in a plane as shown. Find the magnitude of the net electric force on the 3 nanocoulomb charge. That's this one for me. The Coulomb constant is. So, and then I'm going to want the direction measured from the positive x-axis with counterclockwise positive. So what this means is that if I had an axis here, then I'd be measuring and I would get up to 90 degrees, I'd get around to 180, I'd get around to 270. So I just want to measure my angle around this way. So if I'm pointing in this direction, I'd have to give the angle all the way around to this, not just the one down here. So find the magnitude of the force on this charge. Well, this is a positive, this is a positive. It's going to give a force that way. This is a positive, this is a positive. It's going to give a force that way. Since this is a 4 and this is a 9, the distances here are the same, but these are different. So these forces are going to be completely different. So what you're going to want to do is, oh good, and that's 9, and that's 9, and that's 9. So at least my distances are the same. My distances are the same over and up. So I know that the direction of this one is going to be 45 degrees down that way. The direction of this force is going to be 45 degrees up that way. So I'm going to take each force once I solve for it, and that should be easy enough because my r's are going to be the same. My r's, hopefully yours are as well. My r's are going to be the same, and that's going to be, if that's 9, that's 9. That's going to be 9 radical 2. So you can solve for that distance. So I will get this force, and it's at 45 degrees. So then I'm going to have a force up this direction, and I'm going to be looking for my force in the x direction and my force in the y direction for that top one. Well, if this is 45, then this is going to be f sine 45, f cosine 45, which should work out to be the same. So you can solve for the force because you know that, and then you'll find your sine and your cosine to find your y and your x. This one here, this force here, pushing down, is going to be the same sort of thing. I'll have a force this direction, which is made up of a force x and a force y. Well, I know that this y is up, this y is down. I'm going to have some net force between them that's going to be the difference between my y's. So my F net in the y direction is going to be my Fy minus my Fy. And my F net in the x direction is going to be my Fx plus my Fx because they're both pointing in the same direction. Now, the only thing I need to know is this one bigger than this one, or is this one bigger than this one? So is my net force going to be pointing a little bit above the axis or a little bit below the axis? Because my x's are both pointing to the right. So once you get those, then you're going to have, let's say you had a net x this way and a little positive net y that way. You'd wind up with your triangle. So now you have a squared plus b squared equals c squared again. And then this angle you can figure out using inverse sine, inverse cosine, inverse tangent at your choice. So again, a bunch of trig, but you're adding two vectors, and you know how to do that.